In the endless universe, there are countless planets, stars, and galaxies. But without any question, the one that fascinates us the most are black holes. Even though our knowledge is very limited about black holes, we can misunderstand that what we know. For example, should we think of black holes as giant vacuum cleaners that's sucking in everything around them? Do black holes move? Do they all have to be extremely massive? And are black holes really black or even holes at all? If you can't clearly answer these questions, gather around. Today we are diving into black holes and correcting 6 common misconceptions about them. For some reason, when people hear the term black hole, they imagine it as a giant vacuum cleaner sucking in everything around it. However, black holes actually follow the theory of general relativity exactly. Gravity works the same way for them as it does for Earth and for Sun. For example, if we were to replace our sun with a black hole of the same mass, nothing in solar system would change. Except, of course, we would left in total darkness. The Earth and other planets would continue orbiting around that black hole just as they do around the sun, as if nothing had happened. Of course, black holes are far more compressed objects than planets and stars. A black hole with the same mass as our sun wouldn't have the sun's enormous radius of about 7,100 kilometers. Instead, it would have a tiny radius of only about 3 kilometers. It's even hard to imagine an object 233,000 times smaller than our sun but have the same mass. Second one is Schwarzschild radius. You don't necessarily need star-sized masses to create a black hole. Yes, black holes are formed from the depths of massive stars. But at least in theory, we know that it's possible to turn any mass into a black hole. Normally, for a star to collapse into a black hole at the end of its life, it must be at least about 20 times heavier than our sun. For that reason, our sun won't become a black hole. Instead, it will turn into a white dwarf. But stars with a mass of 20 times of our sun or more explode as supernova when the hydrogen fuel in their cores runs out. In this explosion, they eject about 85% of their mass into space, while remaining 15% can no longer sustain the fusion reaction needed to resist gravity. Still, every mass has a Schwarzschild radius. For example, if we wanted to turn our sun into a black hole, we would have to compress its radius down to about 3 kilometers. And finally, if we wanted to make Earth a black hole, we would need to squeeze its radius down to just 1 millimeter. But of course, unfortunately, we currently have no known mechanism capable of doing that. Some people believe that black holes are portals to other universes, or to different places in the universe. If black holes were connected to each other through a wormhole, then perhaps we could start talking about something like that. But at that moment, we have no observational evidence that wormholes or other universes actually exist. Therefore, we cannot say these ideas are true. Another common misunderstanding is that black holes are static, so they will exist forever. That's not true. In fact, it's quite opposite. Due to Hawking radiation, big black holes evaporate very slowly, while smaller ones evaporate much faster, eventually disappearing over time. But don't be confused by the phrase over time. The evaporation periods I am talking about are trillions of times longer than the current age of the universe. When it comes to the movement of black holes, people often think they can't move because they imagine them as literal holes. But we can't think black holes are just holes. After all, we have to remember that they are astronomical objects. And like all other objects, black holes rotate on their own axis plus move through the fabric of space-time. In fact, if galaxies collision occur at the right angle and speed, black holes can be ejected from the center of their galaxies, escaping into intergalactic space. Until now, around 20 such black holes have been detected. There is more. As we know from gravitational waves, black holes can be merged with another one, meaning they are not static objects, as many people assume. Finally, let's talk about the invisibility of black holes. This belief was shattered now that we actually have photographs of black holes. Black holes are not truly invisible, we can observe them. Of course, if you were to look directly at a black hole, you wouldn't see anything. Because for us to see something, photons must reach our eyes, and photons don't escape from a black hole. So how do we detect them? When black holes have their enormous gravitational pull on other objects around them, they can cause strange changes in their motions. Therefore, even though we can't see black holes directly, by observing these abnormal movements of nearby stars, we can tell there is something with immense mass in this area. And that's not all. As you may have seen in black hole photographs released in last years and beautifully depicted in movies like Interstellar, black holes are surrounded by what we call an acceleration disk. It's extremely hot matter rotating at incredibly high speeds. As a result of friction, it generates and emits an enormous amount of heat and light into the surrounding space. Ironically, the brightest objects in the universe form around the darkest ones. By observing these acceleration disks, we can find the location of black holes, meaning they are not as visible to us as they might seem. There are countless fascinating details and mysteries about black holes we haven't touched on yet, but let's end this video here. And remember, what we know about black holes is still very limited. And if you like to see more videos about black holes, don't forget to subscribe and turn on notifications.